Okay, good morning. Okay, good morning, class, right? So, how are you today? Okay, so I think we still have a question, right, to discuss. Okay, I think we stop until here, right? Okay, so I'll give you some time, okay, to answer this question. Okay, then we will discuss. Okay, for question 1A and 1B. Okay, so this one is a specific heat capacity. So what is the specific heat capacity? Right, the amount of heat, right, needed to raise 1 degree Celsius, okay, for 1 kg of substance. Okay, so for this one, there must be the increase of 1 degree Celsius for 1 kg of substance. So that's the meaning of the specific heat capacity. So how much the energy that needed by the object, okay, to increase 1 degree Celsius. But the object must have a 1 kg of mass. Okay, and another one was the formula. You already know that Q is equals to MC theta. Right. So the lower the specific heat capacity, right, the highest the increase in temperature. Okay, so means it's easy for the object to get heated or the object to become cold. Okay, so the lowest specific heat capacity, the faster the object become hot, and the faster the object become cold. Okay. Teacher, I think this one we discussed already. Oh, really? So the number, oh yeah, yeah. So for this one, right? So for this one, I said the 200 gram of water, okay, it mixed with the 800 gram of water. Okay, the temperature for the 800 gram is at the temperature of boiling water, and the 200 gram water, they got the 40 degrees Celsius, okay, of the temperature. So how you want to find the final temperature? Okay, for this one, anyone got idea? So when it achieve thermal equilibrium. So what does it mean when it achieve thermal equilibrium? The heat, right? The heat gain is actually equals to the heat absorbed, right? So how you want to form an equation from that? Or maybe anyone already got the answer for this one? Okay, I give like 2 minutes. Okay. So after that, we teach you how to answer for this question. Haye, do you got the answer? Joey, Ziyin? 85 degrees Celsius. Okay, so that's a Marian answer. Okay, maybe others got different answer. 85 also. Okay. So let's try to answer for this one. So it's still here 200 gram of water, okay? It mixed with the 800 gram of water, or 800 gram of water. So the 200 gram water they got it got the 40 degrees Celsius. So the temperature for the 200 gram of water is 40 degrees Celsius, while the 800 gram of water it got the temperature of boiling water. So the boiling water you already know 100 degrees Celsius. So means the 800 gram of water, it got a temperature of 100 degrees Celsius. So the question says if there is no heat loss to the surrounding. So what is the final temperature when the mixture of the water achieve thermal equilibrium? So there is no heat loss means the total heat energy absorbed is actually the equals to the heat energy release. Okay. So this is the equation. Heat absorbed is equals to heat release. Okay, so what is the formula for heat energy? You already know mc theta, and this one also the energy for heat is mc theta. Okay, all right, so for the next one, so you have to determine which one will the water will absorb the heat, okay, which one will release the heat. Okay, so the absorb which one absorb the heat, which one release the heat? The one with 40 degrees or 100 degrees Celsius? So if 40 degrees Celsius, yes, 40 absorb, then the 100 degrees Celsius will be release the heat. Okay, so when you absorb the heat, so the first one was the mass here. So of course the mass must be in kg. Okay, so the heat absorbed, the mass is for the 40 degrees is 200 grams. So I change to kg 0.2 here. Alright. And for the C, we just can ignore the C because both use the same type of substance. So both using water. So we just can cut off the C here. So now you will leave with m theta. Okay, so the theta here, so the 40 degrees will increase, right? The temperature will increase. Okay, so when the temperature is increased, should be theta minus 40, because it will increase to something higher than 40. So theta minus 40, because theta is actually the temperature change. So what is the temperature change? Final temperature minus initial temperature. So you want to find the final temperature, right? So the final is theta minus 40. So final temperature minus 40 initial temperature, because 40 the temperature will increase, right? Will increase. So theta is the final. So minus 40. Okay, so are you clear for this equation on this side? Anything you want to ask? Or you want me to explain again? Okay, very good. Alright, and then for this part, okay, for this part, the heat will be released. Okay, so what is the mass for the water that will release the heat? So this one is 0.8. I changed to kg. Okay, and how about the theta? So the theta here, the 100 degrees Celsius, it will decrease, right? It will decrease the temperature. So means the 100 minus theta. Okay, 100 minus theta, because it will decrease, right? So they decrease. What is the last temperature here? The final temperature there, the final temperature must be lower, right? So 100 minus theta. Okay, after that, what you have to do, you have to expand it. So 0.2 theta, okay, minus 8, I think. Okay, Is it correct? 0.2 times 40. Is it correct? 8, right? Okay, and then this one is 80 minus 0.8 theta. Okay, so you check my calculation because I didn't use calculator. Okay, so I think it's correct. Yeah. Okay, then you have to find theta. Okay, so this one 0.2 theta plus 0.8 theta equals to 80 plus 8, right? Yeah, so you got 1 theta here is equals to 88 degrees Celsius. So do you know how I calculate this one? I just change here to here, so 0.2 plus 0.8. Okay, and then this one negative plus become positive. So the final temperature is 88. So you just now you got 85, right? Most of you got 85. How you get the 85 degrees Celsius? Oh. So your answer should be 88. So can you understand how to answer for this one? Okay. Is it good? Anyone to ask any question, teacher, about this question? Don't know how to find the value of theta. Okay, so good. So the answer is 88 degrees Celsius. Okay, so for this one, so what's the answer for this one? Let's try to answer. So it said how long does it take for an emission heater of 12 watt to reach the temperature of 200 gram of water by 5 degrees Celsius. So here they already give you the specific heat capacity of water is 4200. So what's the formula that we should use for this one? Yeah, PT is equals to MC theta. Okay, so this one we assume that this is the electrical energy convert to the heat energy, right? So this is the electrical energy convert to the heat energy. So we assume there is no energy lost to the surrounding. So electrical, how much the electrical energy? That is what you get. Okay, for the heat of energy. So it will not be lost to the surrounding. So PT is the formula for the electrical energy. Okay, so PT is actually the formula for electrical energy. Okay, and then equals to MC theta. MC theta is the heat energy. So we use PT is equals to MC theta. Okay, so let's say the question asks what is the assumption that you made here. So the assumption is there is no energy loss to the surrounding. There is no heat loss to the surrounding. Okay, so T is 350 seconds. 350 seconds. So PT is equals to MC theta. So the power is 12. Okay. The time is the one you want to find. M is 200 gram, change to kg. Okay, because of the specific capacity, the unit here is in kg. So you have to change this one to kg. Okay, and then the C is 4200, and the theta is the change of temperature, right? So already give here by 5 degrees Celsius. Okay, so you will get 350 second. Okay, is it correct? Yeah, 350 second. Very good. Okay, for number 4. It says a lead bullet moving at a velocity of 200 meter per second hits a sandbag. Okay, so the temperature of the lead bullet rises by 50 degrees Celsius. Assuming that all the kinetic energy of the bullet is converted into heat energy that heats up the bullet, so calculate the specific heat capacity of the bullet. Okay, so means you need to find C here. Okay, so what's the formula that you should use for this one? It's already said that all the kinetic energy we change to heat energy. Half mv square is equals to mc theta. Yes, very good. So half mv square is equals to mc theta. Okay, but for this one, they didn't give you the mass, right? But most of it is actually for bullets. So we just like cancel it because it's the same thing. Okay. So now you only left you by half v square c theta. Okay, so you need to find the c here. Okay, so I just substitute the value. V is 200 millisecond, right? 200 milliseconds a square here. C you need to find theta is 50. Okay, so what is the form? What is the value of C? 400 J kg negative 1 degree Celsius negative 1. Yes. 400 J kg negative 1 degree Celsius negative 1. So that's the how you want to calculate the specific heat capacity of the bullet. So this one use what principle? This one using what principle? Anyone still remember I said what is the principle that we use? They say if I said just now all the electrical energy change to the heat energy without loss to the surrounding. No. What is the principle that we use here? Not potential energy. No. Principle of what? When I said there is no heat loss to the surrounding, all the energy change to from the electrical energy, all of it change to the heat energy. There is no heat loss to the surrounding. And I said that principle, okay, the energy cannot be destroyed. The energy can only change form to another. Energy cannot be created. Yes, very good. Right? Principle of conservation of energy. So the question asks you, what is the principle that you use there, right? You equal, if you make two energy equal, right? Heat energy equals to the electrical energy. So that one is shows that the energy is all the energy change, right? So means that one is a principle conservation of energy. Okay, so let's say the question asked, you say principle conservation of energy. Okay, sometimes they will ask. Okay, so for this one, it says here a lead ball of mass 320 gram is dropped from a height of 12 meter. The collision between the ball and the ground is a completely inelastic. So inelastic means after it will move a separate way or it will bind to the ground. You move with the separate way for the inelastic. Move separate way or it will attach to the ground. For inelastic, who can remember? Yeah, okay. Inelastic, it attached. If move separately, that one is elastic, okay. So assuming all the energy of the ball goes into heating it, so calculate the change in temperature of the ball. Means you have to find the theta here. So when it has a height of 12 meter, right? So what energy that the that the lead has? What type of energy? Based on the position. What type of energy that the lead ball has when it's at the height of 12 meter? Yes, very good, Marian. So it has a gravitational potential energy. Okay, so means from the gravitational potential energy, it changed to the heat energy. So what is the formula for the gravitational potential energy? Yeah, very good. mgh is equals to mc theta. Okay, So M is the 320 grams. So change to kilogram, it should be 0.32. Because you see here the specific heat capacity, they use kg. So you have to change. Okay, G you take 9.81. Okay, and the height is 12 meter. Okay, and then this one also the mass is 0.32. Okay, so the C is 128. Okay, and then you have to find theta here. It's my calculator. Hmm?
Yang kiri tu kita buat yang kiri.
0.32 9.81 times 12. When you got the answer for this one? I got 0.92. Okay, right. So theta is 0.92 degrees Celsius. Okay, so for every calculation, you have to show the step, okay, how you get the answer. Don't just simply give the answer, right? So you got 0.92 degrees Celsius. Okay, this one because they use G is 10. Okay, this one they use G is 10, so that's why they got this answer. Okay, but actually for your KSSM, okay, your G should be 9.81. Cannot take 10 anymore. Okay, 10 is for the old syllabus. Okay, for your new syllabus should be 9.81. So this one you got like, this why you got 0.9375 because it's take G here as 10. Okay. Okay, so we finish for 4.2. Okay, so let's move on for 4.3. Right, specific latent heat. Okay, so what's the difference between the specific heat capacity and the specific latent heat, right? So let's see what we learn in this subtopic. Okay, so you see here you have to able to define, okay, what is the meaning of the specific latent heat, okay, and then specific latent heat of fusion and specific latent heat of vaporization. Okay, and then you'll be able to state the meaning of the specific latent heat of fusion of ice. Okay, so what does it mean by 3.34 times 10 power of 5? Okay, and then you have to able to state the meaning, okay, the meaning of specific latent heat. So let's say give you the value of 2.26 times 10 power 6. So what is the meaning of that? Okay, and also you have by using the kinetic theory of matter. Okay, so you have to able to explain why the temperature remain constant, okay, during melting and boiling process. Also the temperature increases, okay, after all the ice melts the water. Okay, so let's say this is the ice kacang, right? So ice kacang which colder than surrounding is absorbing heat from the surrounding air. Okay, so what changes happen to the ice kacang? So what changes happen to the ice kacang? Yes, it will melt. So when it will melt, what happened? What is the change of phase there? From white to what? Yeah, from solid to liquid. So that is a change of phase there. So if I say phase mean solid, liquid, gas, right? And so that's another picture here. It shows that a fish can be cooked, okay, by steaming, okay, in a steamer pot. So what changes happen to the water in the steamer pot when it boils? What happened? Yeah, liquid to gas, okay. So what is the process? What is the process name, okay, when the liquid change to gas? Evaporation. Okay, very good. Okay, so this is the latent heat. So if you know that we discussed, right, when the ice is absorbed, heat is changed from, is melting and you change the phase. Okay, you change the phase from solid to liquid. Okay, and then another picture you said just now, okay, when you cook the steamed fish, right, so it will change the liquid to gas. Okay, so what we can, like, imagine, like we can see here that when they absorb, when the heat is absorbed, okay, there will be a change of phase there. Okay, from solid to liquid or liquid to gas. Okay, so latent heat. So latent heat, what does it mean by latent heat? So the heat absorbed or the heat release, okay, at constant temperature during a change of phase. Okay, so whether it's solid to liquid or liquid to gas or gas to liquid, so the heat that absorb or release, okay, that one, the heat they use the heat to change the phase. So that's the meaning of the latent heat. But the temperature must be constant. There will be no increase in temperature. Okay, so it's different from the specific heat capacity. The specific capacity do what? It absorb the energy, the heat energy, to increase the temperature in 1 degree Celsius. Right? That is the specific heat capacity. There must be increase in temperature. Okay, but for the specific latent heat, the temperature will not increase. So what will happen is only change of phase there, from solid to liquid or liquid to gas or gas to liquid. Okay, so only the change of phase there occur, but there is no change of temperature. Okay, so that is the latent heat. Okay, so this is the process. So let's say if I use the ice, okay, and then this is water and this is the water vapor. Okay, from the ice to liquid is the process of melting. Okay, and this one we already know the heat must be absorbed. Okay, and for liquid to gas, okay, the process is evaporation. Okay, and this one also the heat must be absorbed. Okay, and then they say we reverse it. Okay, gas to liquid. Okay, the process we call it as the condensation. Okay, and this one the heat is released. Okay, the heat is released. Okay, and then after that, liquid to ice. Okay, liquid to ice. So that process we call it as a freezing. Okay, and this one also the heat energy is released. Okay, so remember for the latent heat, all the heat is absorbed or the heat is released. Okay, it's actually used to change the phase. Okay, whether solid to liquid, liquid to gas, or gas to liquid. Okay, and also the temperature must be constant because all the heat energy is used to change the phase. So there will be no increase in temperature. Right, so that is the latent heat. Okay, so there is a four main changes of phase. Okay, so this one is the melting. Okay, I already discussed this now. This one is the boiling. Okay, from the liquid to gas, and this one gas to liquid we call it as a condensation, and the liquid to solid we call it as a freezing. Okay, so this one I just discussed just now. So for activity 1, right, to study the change in temperature when the heat is supplied to a solid at its melting point. Okay, let's say you heat the ice in a beaker slowly. Okay, so it says here, do the thermometer reading increase? Okay, so now it changed the phase, right, from the ice to water. Okay, so from ice to water, okay, there is no change. Okay, because all the heat energy used to melt the ice, so there is no change in temperature, so the temperature remains the same. Okay, so what is the effect of the heat supply, okay, to the ice? Okay, so for this one you already learned the arrangement of the molecule for solid is like this. It's very close to each other. Okay, and then if you want to change to liquid, so the liquid is much further, right? So means they want to form a distance, okay, between the molecule. So you need to break the bond here. Okay, so you need to break a bond here. So all the heat energy, okay, that being given is used to break the bond here, so it can move freely like the liquid, okay, like the molecule in the liquid. Okay, so that's why the temperature will not increase because all the heat energy used to break up the bond between the molecules. Okay. Okay, what happened to the temperature when ice melt? Okay, so the temperature will remain the same. So as I told you, because all the heat energy used to break up the bonds. Okay, and what happened to the heat supply to the melting ice? So this one already discussed. So the heat absorbed by the ice is used to break up the bond between the molecule, and there will be no increase in kinetic energy. So there will be no increase in speed, okay, for the ice molecule. Okay, so because all the energy being used to break up the bond. Okay, so the temperature remains same, okay, when the ice change to water. So this is the melting process. So let's see for the boiling process. Okay, so what happened what is the effect of the heat to the water? Okay, the temperature will increase. Okay, so the next step is continue to heat even though the water in the beaker is started to boil. Okay, so is the temperature rise up? So for this one, no. Because at this time, at the boiling point, all the water will change to gas. Okay, so they need the energy to break up the bond. Okay, from the liquid, so it can change to gas. Okay, because you want to move much further, so it need more energy to break up the bond. So it will use the energy so to break up the bond. So the temperature will not increase. Okay, if not, what is the effect of the heat supply to the boiling water? So it will break up the bond between water molecule and change to steam. So for this one, name the heat absorbed or given out at the constant temperature during change of phase. Okay, so before that, all right, I would like to add something here. Okay, so for this one, what is the type of latent heat? Okay, that we use here. Okay, so for this one, it changed from solid to liquid. Solid to liquid. Alright. So this one we call it as a, yes, latent heat of fusion. Okay. If liquid change to solid also, we call it as a latent heat of fusion. Okay. Solid to liquid or liquid to solid, both of it use the same latent heat of fusion. Right. Very good, Kai. Okay. And for this one, for the boiling, this one from liquid to gas, right? So what type of latent heat used here? What type of latent heat used here? If that one is fusion, and this one is what? Yeah, latent heat of vaporization. Okay, so this one wrong spelling. Okay, so latent heat of vaporization. Okay, so this one, if liquid change to gas, yeah. Okay, and gas change to liquid, both of it we call it latent heat of vaporization. Okay, so what we can conclude here, solid to liquid, liquid to gas, okay, or vice versa. Okay, so this one, latent heat of fusion, and this one, latent heat of vaporization. Okay, this one. So whether solid to liquid, liquid to solid, both have same name, latent heat of fusion, and they need same amount of energy also. Okay, liquid to gas, latent heat of vaporization, gas to liquid also, latent heat of vaporization. Okay. Alright, so until there, if anything you want to ask me. No. So you are clear, right? Latent heat means there is no increase of temperature. All the energy used to break up the bond. Okay, and also there will be only change of phase there. Okay, means there is no increase in kinetic energy. Okay, so the next part is you have to define what is the latent heat. So the heat absorbed or released at the constant temperature during change of phase of a substance. So amount of heat energy, okay, used, right, to change the phase of the substance, okay, without increase in temperature. Must have the word constant temperature or without increase in temperature, and must have the change of phase there, and must have the amount of heat energy. So that the keyword that you need to put, okay, need to write, okay, if you define the word of latent heat. Okay. So this one for this one also I already discussed. Okay, latent heat of fusion, latent heat of vaporization. Okay. Okay, so for this one, why the temperature remains constant during a change of phase? Okay, so this one for solid to liquid, right? So we already know why, because the energy used to break up the bond between the molecule. Okay, so the kinetic energy of molecule does not increase. Okay. Alright, so what happened? Okay, when a liquid boil, the heat absorbed is used. Okay, so this one from liquid to gas. Okay, for liquid to gas, just now for solid to liquid, the energy is used for only one reason, because there you need to break the bond between the molecule. If for solid to liquid, okay, solid to liquid, only one reason, only one reason. What is the use of energy? So all the energy will be used to break the bond between the molecule. Okay, but for the liquid to gas, there are two functions of the heat energy supply. Okay, so what is the first function? The first function, of course, to break the bond. Okay, from solid liquid to the gas. Okay, so what is the second one? Okay, so the second one is actually to do work against atmospheric pressure. So you know, because then the liquid change to gas, so the gas have to go to the surrounding, right? So they need to overcome one more, okay, one more obstacle, that is the atmospheric pressure. Okay, so that's all the energy used to the first one for solid, from liquid to gas. The first one, they use the energy to break the bond, and the second one, okay, to work against the atmospheric pressure so it can move freely to the surrounding. Okay, so that's why, okay, that's why the latent heat of the vaporization is higher than latent heat of the fusion, because they need to overcome two things, okay, the bond and also the atmospheric pressure. But for only solid to liquid, they only need to overcome one thing, there is a bond, okay, the molecule bond. Okay, so that's why the latent heat of vaporization is higher than the latent heat of fusion. Okay. All right, so this one is the graph, okay, for the heating curve, right? Heating curve. Okay, so for this one, okay, at this part, okay, at this part is actually solid. Okay, and this one is solid plus liquid, and this one is a liquid, and this one is a liquid and gas, and the last one is the gas. Sometimes they use water, sometimes they will use a naphthalene. Okay. Okay, so we put here, this is solid, this is ice water. Okay, you already know what is the phase, okay, for each part of the graph. Okay. Okay, so let's see the first one. Okay, so you can see there is a change of temperature here. So I want to ask you, we already learned there are two type of heat, right? The specific latent heat and the specific heat capacity. So for this part, okay, for this part, actually this one is what type of heat? Specific latent heat or specific heat capacity? Specific heat capacity, right? So this one is specific heat capacity. So the heat energy, if you want to calculate, of course you have to use MC theta, right? And the kinetic energy at this part, it increase, okay, and the temperature must be increased because specific heat capacity must involve in the change of temperature, right? And then the state of matter, no change, because this one is a specific heat capacity. Only the phase change is only occur at the specific latent heat. All right, and the content is in solid. Okay, this one is the, you can see there is no change of temperature. So this one is a specific latent heat of fusion. Yes, very good. Specific latent heat of fusion. Okay, so at this time the solid begins to melt. So at the point M, it begins to melt. Okay, but at the point N, all the solid is already melt. Okay, at the point N here, all the solid already melt. Okay, at the point M and N is in the process of melting there. Okay, so for this one, you want to calculate the heat energy, we use ml. Okay, Q is equals to ml. So ml is actually for the specific latent heat. Okay, and the kinetic energy is constant because of what? Because all the energy is used to break up the bond. Okay, and the temperature also constant because all the energy, okay, is not used to rise up the temperature, is only used to break up the bond. Okay, and the content here is solid to liquid because there is a change of phase there, right? Okay, and then for this part also, okay, for the water it seems like the Lm, but this one use the specific heat capacity. Okay, MC theta, okay, there will be a kinetic energy increase and the temperature also increase. Okay, because specific heat capacity, right? But there is no change of matter, all right? And also the content is all liquid because there is no change of phase occur at the specific heat capacity. Okay, for the water and gas, okay, so you can see there is a change of phase here and also the temperature is not increased. Okay, so this one should be specific latent, specific heat of specific latent heat of vaporization, right? So for this one, Q is equals to ml, alright, and the kinetic energy is constant and also the temperature is constant, okay? And the state of matter is changed because it changed from water to gas, okay, and the content is the liquid and gas, okay? But for this one, okay, for this one, remember the energy used to break up the bond, and another thing is to works against the atmospheric pressure. Okay, so it can move freely around, it can move freely, okay, to the surrounding because now it changed to the gas. Okay, and the last one is the gas is actually for the specific heat capacity. You can see increase in temperature and also kinetic energy, but there is no change of state there. Okay, state of phase there, so means you should be specific heat capacity. And the content is only gas. Okay, that is the heating curve. Okay, so how about the cooling curve? Okay, for the cooling curve, for this one, all heat will be released. Alright. Okay, so heat energy MC theta release. Okay, kinetic energy decrease. Alright, there is no change of state of phase here. It's only gas. Okay, so we use MC theta. But for this one, this is the, there is no change of temperature and also there is a change of phase here from the gas to water. So this one should be specific latent heat of vaporization. Okay, it's just same. Gas to water or water to gas. So it's just same. Just both has a specific latent heat of vaporization. Okay, and water again, there is a change of temperature. So this one is a specific heat capacity. So MC theta, the kinetic energy decrease, temperature also decrease. Okay, but there is no state of matter change because this is not the specific latent heat. Okay, and also this one, okay, this one also is the specific latent heat of fusion. Okay, and it's only change the phase from the water to ice. Alright, and the temperature must be constant because all the energy is used to form a bond. Okay, form a bond between the molecule. Okay, and this is one is the solid, right? This one is the MC theta, specific capacity, all the kinetic energy and also the temperature is decreased, and the state of matter, there is no change. Okay, and also the content is solid. So for this graph, any question you want to ask? No. Are you clear about this one? Okay. Alright, so just now we only learn about latent heat, right? And now we move to the specific latent heat. So what is the difference between the latent heat and the specific latent heat? Okay, so remember for the heat capacity, right? Heat capacity and the specific heat capacity. What is the difference? The difference is only the mass, right? For the specific heat capacity, the object must have the 1 kg of mass. Okay, so same like the specific latent heat, okay, it must have 1 kg of substance. Right? So the heat absorbed for 1 kg of substance to change a phase at the constant temperature. So that's the meaning of specific latent heat. So the only thing that you need to add is the mass here, 1 kg of mass. Okay, but it's same the meaning of the latent heat just now, but this one you only add 1 kg, okay, for the mass. Okay, I got one question to ask. Okay, before that, so this is the formula. Okay, Q is the quantity of heat or heat energy. So the unit must be in joule. Okay, M is the mass, must be in kg. L is the specific latent heat. So this one is the fixed value. If there's sometime they will give to you or they want you to find it. So it's just you see the info of the question first. Okay, but the unit is kg -1. Okay, so you can see this different from the specific heat capacity, right? For the specific capacity, there has a J kg -1 degree Celsius -1 because there is an increase in temperature. For this one, no increase in temperature, so only J kg -1. Okay, so there are two types, specific latent heat, okay, fusion and also vaporization. Okay, so this one I will not explain. Okay, this is the question I want to ask. Okay, can you give me the meaning of the specific latent heat of fusion of ice is if it's given the value of 336,000 joule kg -1. Can you change it to words?
Nah,
336 joule of heat energy is required to change 1 kg of ice from solid to liquid at a constant temperature. Okay, so I will check one by one first. Okay, we start from the Shuangqi. Okay, Shuangqi, this one you don't need to include the kg -1. Okay, because this one you already mentioned here for 1 kg, right? So no need to put, only you put here 336,000 joule, okay, of heat energy, because amount of heat energy means what is the unit for heat energy. So let's say if the question asks you in the general form, right? So what is the meaning of the specific latent heat? So what you said, amount of heat energy, right? Amount of heat energy required. So what is the unit for heat energy? Only joule, right? So you don't need to put the kg one, the kg -1, right? So it's absorbed by the 1 kg ice to change from solid to liquid at the constant temperature. Okay, correct. So this one also same zigging also. Okay, don't put. Yielding also please don't put. Okay, only put joule because amount of heat energy, right? So heat energy is only joule. Okay. To change from solid to liquid, to change from solid to liquid. Also Junhin, okay, no need to put. Right, and I said, okay, Chushan, okay. Okay, okay. Kenny, okay. So this one also, please don't put kg -1 because amount of heat energy. You need heat energy is joule only. Okay. Okay, very correct. Okay, let's say this is because they give you a diagram here, right? And so ice means you already know should be specific latent heat of fusion. So there is a change from solid to liquid, right? So let's say it's a very give you a general, like, so what does it mean by specific latent heat of fusion? Only that. Okay, what does it mean by specific latent heat of fusion? Didn't give you like ice or water or not. So what should you answer? What is the sentence that you should put there? What is the meaning? Okay. So my question is, what does it mean by, what is the meaning, sorry, what is the meaning of specific latent heat of fusion? Hmm. Can you give me the meaning for this one? The amount of heat energy absorbed to change state from solid to liquid. Hmm. Okay. All is wrong. Okay. Remember just now when I said, right, specific latent heat of fusion is not just solid to liquid. It's also from liquid to solid. Okay. For this one, I accept because it's asking you about the ice. So of course, ice have to change to solid. Okay, solid to liquid. So that's why I can accept. Okay, but this one they didn't mention is it ice or is it water, right? So what you have to do, okay, you cannot say like only solid to liquid. You have to say solid to liquid and vice versa. So means both of it is using the same meaning. Okay, so for this one, the answer should be the amount of heat energy. Okay, so I just said just now, amount of heat energy. Okay, to change the phase. Okay, from the solid to liquid, or liquid to solid, or you can say solid to liquid, or vice versa. Okay, for 1 kg of substance, right, without change in temperature, must take both of it. Okay, because this one they didn't mention for you, is it for ice or is it for water? Okay, so we don't know what change the state, what is the phase changes that occur here, right? So for this one is okay because this one already mentioned the ice. Okay, so are you clear about that one? Okay, only if they say for ice, then you can say solid to liquid, but this one they didn't mention anything, you have to put both. Okay, all right, so for this part, what does it mean by specific latent heat of vaporization of water? The amount of heat required 1 kg of water to change from liquid to gas is yes, okay, correct. Junhin, 1 kg of water to change from liquid to gas. Yes, correct. Okay, Yang 2000 is also 1 kg of liquid to gas at constant temperature. Okay, so most of you got it correct. Okay, so this is the answer. Okay, actually for this one, I just explained just now, asking you actually why does the fusion of ice is only 3.34 times 10 power of 5, right? But the specific latent heat of vaporization is 2.26 times 10 power of 6. Okay, so this one means the evaporation, the specific latent heat of vaporization, they need a lot of energy, okay, compared to the latent heat of fusion. So why does the value different? I already told you just now, because for the vaporization they need to overcome two things. The first one is for the bond molecule, okay, to overcome the bond, the molecule bond, and the second one is actually to work against the atmospheric pressure, so it can move freely to the air. Okay, so this one I will not explain anymore. Okay, so this is the formula for the MC theta. This is for the Q equals to ML. Okay, exercise 1. So before we did the exercise here, I just want to see the application. And then after that, we go back to the exercise. Okay, wait for a moment. Okay, so the application of the specific latent heat in daily life. Okay, so the first you have to explain how the sweating can take away heat from our body, and how steam to be used for cooking by the method of steaming. Alright, and also how fish can be kept fresh. Okay, so how does the drink can be cooled? Okay, by adding in several cubes of ice. Okay, so just now we already learned the ice will absorb the heat from the drink. Okay, and it will change the ice to water, right? So there is a change of phase there, so specific latent heat of fission. Okay, so that's why when the heat it absorb the heat from the drink, so the temperature of the drink will decrease, so that's why the drink can become cold. Okay, so the first one, when ice melt, okay, when the ice melt, it absorb a lot of energy, okay, amount of heat energy from the water, okay, from the drink. So the drink will lose the heat, okay, and the temperature will be lowered, okay. And for the ice, it will become water because there is a change of phase there, okay, from the solid to liquid, okay, and the name of the heat is called as the specific latent heat of fusion. Okay, for the fish, right? The freshness of a fish and meat can be maintained by placing them in contact with ice. Okay, so explain. So the ice will what? The ice has the largest specific latent heat, so it will absorb the large amount of heat from the fish. Okay, and then it will melt. Okay, so the temperature of the fish will be decreased because the heat energy already being absorbed, okay, by the ice, okay, and then the fish can be kept at low temperature for a longer time. Okay, and then the next step is how steam is used to cook food. Okay, so when there's, of course, you have to put the water below of the fish, right? Okay, at the bottom part, so the water will be boiled. So when the water boil, it will change the water to the gas. Okay, so and then when the water vapor, okay, it hits the lid here, the cover here, okay, so it will change the water vapor back to the water, right? The water vapor change back to the water, change back to the liquid. Okay, so the first one I explain again. So the water will be boiling, so the water will change to gas or water vapor. So when the water vapor hit the cover here or the lid here, the water vapor will change back to the liquid, so the process of condensation. Okay, gas to liquid. Okay, so when the process from gas to liquid, okay, the condensation, you already know, the heat is released, right, during the condensation. Okay, so during the condensation, the heat will be released. So the heat released by the process changing from gas to liquid is used to cook the food here. Okay, so I explain again, the water will be boiled and it will change to the gas, and then when the gas hit the lid or the cover here, it will change back to the liquid. Okay, so you know, from the gas to liquid, the heat will be released. Okay, so the heat release is used to cook the steamed fish here, right? So this is the explanation. So the specific latent heat is released directly to the fish. So the fish is enabled to be cooked, okay, faster. Okay, so the next one, explain why our bodies feel cold after sweating. Okay, so the sweats on the body evaporates. Okay, so it absorbs specific latent heat of vaporization from the body. So you already learned in science, right? So when the sweat occurs, it will take away your the heat from your body too. So when the evaporation occur, okay, it will take out the water, the sweats, okay, from your body. So at the same time, it will take the heat also. So that's why the body feel cold. Okay. And why does the burn due to the steam is more serious than the burn due to hot water? Okay, because the water has a larger specific latent heat of vaporization. So when the steam condenses on the skin, the large amount of heat is released to the skin. Okay, so the water has a larger specific heat of vaporization. This is also same like the fish. Okay, so when it turn into the steam, the gas, okay, and the gas hit you the hit your skin, right? So it will change the gas to liquid back. Alright. So at the time when the gas change to liquid, the heat is released. So the heat will be released on your skin. Okay, so that's why the injuries is more serious. So this one is same like the fish. Okay. Alright, so we move on to the question. Okay, so that is the application. So let's see question number 1 first. Okay, can you try to answer? $2,226,000. Any other answer? Alright, so let's see. What's the formula that you use in this question? What is the formula that you use for this question? Q equals to ml. Okay, so Q is equals to ml. Okay, so what is the Q here? Q is the quantity heat of energy. So this one is the Q here. Okay, the unit must be in joule. Okay, and what about the mass here? Mass is 2. Okay, and the L here you need to find, right? The specific latent heat. So you got 226 kg negative. So that's question number 1. Okay, so is there any question you want to ask for question number 1? This one just straightly use the formula, right? Okay, correct. Okay, how about this one? So you see here an emission heater supplies heat at the rate of 50 joule per second. So some of you must ask, right, what is the 50 joule per second? So this one is actually power, because power is equals to work over time, right? So work is actually the unit is in joule, time is actually the unit in second. So that's why you got JS negative 1. But this one is JS negative 1 is actually equals to what? So after that, it said the liquid is brought to be to its boiling point, all right, and keep boiling for 2 minutes. Okay, during which the time the mass of liquid loss is 40 gram. So what is the value of the specific latent heat vaporization of the liquid? So for this one, what is the formula? PT is equals to ml. So what is the assumption energy that you assume here? The electrical energy is equals to the specific latent, heat latent heat energy that we use here, right? Okay, so PT is equals to ml. Hmm. Do I need to change the, yeah, change to kg? 1,000 or 150,000, 150,000 joule. Okay, so let's try whether it's correct or not. So you got this one, your power is 50, right? And how about the time here? The time you have to change to second, okay? Remember this one change to second because this one is second also. Okay, so you got 120 and the mass is 40 gram is 0.04, right? I take my calculator. 50 times, 50 times 120 divided by 0.04. 150,000. Alright. Make sure you put the unit, okay? Because when I mark your paper, some of you didn't put unit. Okay. If for KBSM, for paper 2 is okay if you don't have unit, they still give you mark. Okay, but for KSSM, I just like I think last year when I go to the meeting, right? So he said that starting from yours, okay, for KSSM, unit is very important. Okay, so you need to know the unit for every calculation that you do. Okay, so this one they change to the prefix, so to the standard form. Okay, if you want to change, you can change. If you don't want, also can. Right. So let's see question number 3. So it says here ice cube of mass 50 gram at 0 degrees Celsius is heated by 50-watt heater. So the ice take 5 minutes to melt completely. So what is the specific latent heat of fusion of ice? So this one we use what formula? PT equals to ml. Okay, correct. So PT is equals to ml. P is the 50. Time is the 300, right? Okay, mass is 0.05. So you need to find the L here. So what is the answer here? 300,000. 300,000 JKG -1. So let me check first. Okay, correct. Okay, 300,000. This one they changed to the standard form. Okay, for number 4. So it says here the emission heater rated at 500 watt is fitted into large block of ice at 0 degrees Celsius. So the specific latent heat of fusion is 3.34 times 10 power of 6. Okay. And how long does it take to melt the 1.5 kg of ice? Okay, so for this one also we use the PT is equals to ml. So you see mostly we use the PT is equals to ml, right? So the power is 500. The time is the one they need to find the time here. The mass is 1.5. The L is 3.34 times 10 power of 6. So what is the time you got here? 10,200 seconds. Okay. So if you didn't mention what you need, okay, it's at the end what you need, that's the question one. So you can put the second, or maybe you
Yeah.
want, you can change to minute also. Okay, sorry, this is 1,002. Okay, sorry, I see wrongly. 1,002 second. Okay, 70 70 minutes. How can you get, someone got, oh, because this one is 10 power of 6, right? So should be 10,000 to 10,020. Correct. Okay, so this one, don't look at this one. This one is wrong. Okay, so put your answer because this one is the value of the, okay, of the specific latent heat of fusion. Okay, so your answer is correct. Okay, this one I leave it to answer. This one because it's same like question number 4. Okay, so you can copy down first for this one. It's just same like question number 4. You need to find the time. If you already done copy, can you tell me so I can move to the next slide? There's one question that I want to discuss with you. Done. Okay. Yes, this one. So for this one is a question asks you to find, alright, the amount of heat energy supplied. So it said it heated the water, okay, at 30 degrees Celsius, okay, until all is converted to steam. So what is the amount of heat energy supplied to the water, right? So start from 0.5 kg, okay, of water at 30 degrees Celsius is heated until all of it converted to steam. So for this one, 30, you already know, right? You already know the boiling point is 100 degrees Celsius. Okay, so is the temperature start from 30, right? So it need to reach 100 first. Okay, then after that you can change to steam. Okay, it's just like in the middle, right? This. Okay, and this is 100 degrees Celsius, right? This is the boiling point. Okay, and 30 is, let's say, somewhere around here. Okay, so you need to increase the temperature first, and then after that it can be changed to the gas, correct? So for this one, the increase of temperature here is a MC theta, is the specific heat capacity. So you need to use MC theta, okay? And then after that, after it completely, okay, change to steam, okay? So this one is ML. So MC theta plus ML, okay, to change from water at 30 degrees Celsius to 100 degrees Celsius and then change to the steam. Okay, so can you understand how do I get this one? MC theta and ML. Okay, right? So MC theta is used to increase the temperature here, okay? And ML is actually for the liquid to change to gas for this one. So I have to add both of it. Okay? So MC theta, try to calculate for this one. The MC theta is what? MC theta is 0.5, C is 4200, and the theta is 100 minus 30. Okay? Shwanky, that one is for MC theta, right? Or you already calculate both of it? Or already calculate both of it? Okay. Huh? How can you get it 4000? Wait. I got 147. Oh, okay. Alright, and then for the ML is, this one is for MC theta, okay? For the ML is, this one is completely, right? It's completely changed. So means the mass is also same because 0.5 kg water, all that we change to steam. So 0.5, same, okay? And the L is 2.26 times 10 power of 6. So I will get 0.5 times 2.26 exponent 6. So you will get 1.13, 1.13 times 10 power of 6, right? It's like 1 million something, right? 1,130,000. So I change to prefix to the standard form is much easier. 1, 2, 3, 4, 5, 6. Okay, and then you have to add with the 140,000 47,000. So you get 1.28 times 10 power of 6. Did you round off, Z? Did you round off to the two decimal point? Because it should be 1277, right? So 7 is more than 5, so you have to add 7 to plus 1. Okay, so 1.28 times 10 power of 6 joule. So let's check whether the answer is correct. Okay, so yes. Okay, so this one they give you, give the answer in the standard form. Okay, can give answer like this also. Okay, so for this one is same like number 6. Okay, oh no, this one is not same. Okay, so let's see question number 7. Because it says here is heated until half of it. So now the, okay, so let's try to, you try to answer first. Okay, you try to answer first. Anyone that got the answer already? But this one is also same because the water is 28 degrees, right? So you need to change to steam. So means they still need to increase the temperature until 100 first. Okay, and then after that, you can use ml. Okay, for this one is actually mc theta plus ml. Okay, but there's a problem here because it says only half of it changed to steam. So for the ml, you cannot put 3.2 because just now the question, the number 6 question is said all of it converted to steam. So there's no problem. You can just take 0.5. But for this one is 3.2. Okay, so only half of it changed. So should be like half from 3.2 is 1.6. Correct. So you need to ml is 1.6. 1.6 times 2.26 times 10 power of 6. So you got 4.58 times 10 power of 6. So let's say his answer is correct or not. Yeah, for so here also MC theta, M is 3.2, C is the 4,200. Theta against the the change of temperature. Okay, so should be 100 minus 28. Okay, so don't forget, don't just really take 100 or 28. So you have to minus. This one is the change of temperature. Okay, and then plus ml. So m because here, why 1.6? Because only half of it. So means there's still 1.6 of water, okay, inside of it that is not changed to steam. Okay, so 1.6 times 2 to 6, okay, and then you just add both of it, so you got this question answer. Okay. Okay, so we finish for specific latent heat. So are you clear about the specific latent heat? Okay, so I will assign homework for you for this subtopic. Okay, so you try to answer, right? And okay, can I ask for your help? Okay, so let's see if you don't know how to answer. Okay, can you please leave it empty? Okay, leave it empty. If you don't know how to answer, leave it empty. Please don't copy your friends. Okay, don't take the answer from anywhere. Just leave it empty. Why? Because that thing mean I know that you have a problem to answer in that question. So you see, let's see if I so many people don't understand. So maybe I know, oh, it means you didn't understand for this part. So maybe I can teach again. Okay, I will give more exercise. Okay, to help you. So please, okay, don't copy your friend because I noticed some of you the answer is very very same. It's just like same sentence, okay. Even the spelling wrong also you copy, okay. So please, right? If you don't know, please leave it empty. I will not be angry at you, but don't like give me empty paper lah. Of course, like and there must be something that you can answer, right? Okay. So please leave it empty. Then I will know which part you don't understand. Then maybe I can help you in that. Is it okay, class? Can you help me with that? Right? Okay, thank you. So we see you on I think on Thursday, right? Okay. So on Thursday we go for the gas law. Okay. So thank you. Okay. Have a good day. Right. Okay. Bye bye. Bye bye. Welcome.